In this lesson, we're going to discuss patch management. So, what exactly is patch management? Well, patch management is the planning, testing, implementing, and auditing of software patches. Patch management is critical for providing security, increasing uptime, ensuring compliance, and improving features in your network devices, servers, and clients. Patch management increases the security of your network by fixing known vulnerabilities in your network devices, servers, and clients. And in terms of servers and clients, patch management is going to be conducted by installing software or operating system patches in order to fix bugs in the system software. Now, patch management can also increase the uptime of your systems by ensuring that your devices and software remain up to date and don't suffer from resource exhaustion or crashes due to vulnerabilities inside of their code. Patch management is also used to support your compliance efforts. Now, one of the biggest things that's looked at from a compliance standpoint is how well your patch management program is being run and how effectively your systems are being protected against known vulnerabilities like those CVEs that have patches associated with them. Patch management is also going to be used to provide improvements and upgrades to your existing feature set. While many patches will only fix existing problems or bugs, there's also other types of patches out there that include feature or functionality updates. By ensuring that you're running the latest version of the software and that it is fully up to date and patched, you can ensure that you have the best feature set available with the highest levels of security. Now, as you can probably imagine, there are a lot of different patches out there because each manufacturer is going to create their own patches for their applications and software. Part of our job as cybersecurity professionals is to be able to keep track of all the various updates and ensure that they're all being installed properly throughout our network to all of our different endpoints to fully harden our network devices, servers, and clients. Now, that's a pretty big job, and patch management is not just concerned with ensuring that a patch is installed, but also that it doesn't create new problems for us once we install that patch. After all, patches can also have bugs in them, just like any other piece of software can. Therefore, to effectively conduct patch management, you really should follow a basic 4-step process of planning, testing, implementing, and auditing. Now, step 1 is planning. Planning consists of creating policies, procedures, and systems to track the available patches and updates, and then having a method in place to verify that they're compatible with your systems. Planning is also used to determine how you're going to test and deploy each of those patches before you install them. A good patch management tool can really tell you whether or not the patches have been deployed, installed, and verified functionally on a given server or client. For example, in a large enterprise network, you might use the Microsoft Endpoint Configuration Manager, or you might buy a third-party tool to help you conduct your patch management. Step 2, testing. Now, while we're conducting patch management, it's always going to be important to test the patches we receive from the manufacturer prior to automating its deployment throughout your entire network. As I said before, while a patch is designed to solve one problem, it can often insert new code that creates new problems for you if you're not careful. Within your organization, you should have a small test network, lab, or at the very least, a single workstation that you can use for testing a new patch before you deploy it across your entire network environment. After all, many of our organizations have unique configurations within our networks, and that can actually break some of the security patches when you try to install them. So, while manufacturers are attempting to ensure patches are not going to cause harm to our systems, this simply cannot be guaranteed because every network has its own individual configurations. So instead, it's much better to find out that the patch is causing issues in your lab environment before you start pushing it out across 10,000 workstations and then have all your end users yelling and screaming at you because their systems are crashing and they can't get their work done. Step 3 is implementation. Now, after we test the patch, it's going to be time for us to deploy it to all of our workstations and servers that need that patch. You can do this manually by going to each system and installing it, or you can do it automatically by deploying the patch to your client's workstations and servers so that it's installed and moved into a production environment. Now, if you have a small network with only a few clients or servers like your home network, you may choose to manually install the patch across the network. But if you're working for a large company that has a really big network, you're going to want to use some sort of tool to perform your patch management. Now again, Microsoft provides a great tool known as the Microsoft Endpoint Configuration Manager that you can use for this purpose, or you can license a third-party patch management tool that has additional features and functions that you may be interested in. Now, some organizations do rely on automatic updates using the Windows Update system, but most large organizations won't do that, and instead they want to have complete control over the installation of patches. For large organizations, it is really highly recommended that you centrally manage your updates through an update server instead of using the Windows Update tool. By doing this, you're going to be able to test the patch prior to deploying it inside of your network environment. To disable Windows Update on your systems, you simply need to disable the Windows Update service from running automatically on the workstation whenever it's being booted up. Now, if you have a lot of mobile devices in your network, you also need to implement patching there too, and you do this through an MDM or mobile device manager. Now, even if you don't have a dedicated test network or lab environment to use during your testing phase here, you can split up your production network into smaller groups and use those as a form of test environment. For example, in one of the large organizations I led in the past, we actually used this concept of patch rings when we're deploying our new patches. Inside of patch ring 1, we only had 10 or 20 end-user machines that we needed to deploy our patches to first. Then, if nothing was broken and we didn't hear about any issues, we would deploy it out to patch ring 2, which contained 50 or 100 machines. This included our system administrators and our service desk workstations too, so we could see quickly if something was going wrong. After that, we'd move into patch ring 3, which contained about 1,000 to 2,000 machines. And once that was successful, we moved into patch ring 4, which included the rest of the network, which was about 10 to 20,000 machines at the time I was working there. Now, the benefit of doing these types of deployments as we move through these various patch rings is that if there's an issue, we're only affecting a smaller group of users before we break all 10,000 or 20,000 user computers, and this saves us a lot of work at the service desk because we're not going to have to field 10,000 calls, we'll only have to field 5 or 10 calls. Now, step 4 is auditing. Auditing is important to ensure that you understand the client status after you conducted your patch deployment. During auditing, you're going to be able to scan the network and determine if the patch was installed properly and if there's any unexpected failures that may have occurred because of that installation. Again, using a tool like the Microsoft Endpoint Configuration Manager or a third-party patch management tool will be able to conduct scanning and verification of your workstations and servers for you, and this will help ensure the patches have been properly installed. Now, if you're using Linux or Mac-based systems, they also have built-in patch management systems too. For example, in Linux, you can use a package manager to deploy RPMs or packages of those patches to all of your servers and workstations, and the same concepts and principles apply like the ones we were talking about when using the Microsoft Endpoint Configuration Management tool. Now, in addition to conducting patch management across our workstations and servers, it's also important that we conduct firmware management for all of our network devices. After all, our network devices like our switches and routers are all running a form of software known as firmware on those devices to be able to provide the operating system to them. If your network devices don't contain the latest and most up-to-date firmware versions, then you could have security vulnerabilities and software bugs that could be exploited by an attacker. If you look at the Common Vulnerabilities and Exposures or CVE website, you'll see a long list of vulnerabilities that are identified in various Cisco networking devices as well as other brands too. So just like you need to patch the operating system of a Windows, Mac, or Linux computer, you still need to update the operating system of your network devices. In a Cisco device, this operating system is known as Cisco's iOS, or the Inter-Network Operating System. To update the iOS version, you need to flash the firmware on that networking device. Now, some device manufacturers like Cisco do provide a centralized method of conducting firmware management in your enterprise networks. For example, Cisco uses the Cisco UCS Manager to centralize the management of resources and devices and to conduct firmware management for server network interfaces and server devices. There are also third-party tools like Device Expert by ManageEngine that allows you to upgrade, downgrade, and manage the configuration of the firmware on all of your network devices using automation, orchestration, and scripting. The bottom line here is that you need to have firmware management in place to ensure that you have the right firmware versions loaded onto your network devices in order to secure your devices, just like we do for our workstations and clients by using patch management. So remember, patch management is the planning, testing, implementing, and auditing of software patches. Patch management is critical for providing security, increasing uptime, ensuring compliance, and improving features in your network devices, servers, and clients. To conduct patch management at scale, though, you do need to use either a tool, automation, or orchestration to ensure that all your network devices, servers, laptops, and mobile devices remain up to date and patched against any known vulnerabilities.